Hello viewers. In this lecture, we are going to discuss about the topic named Architectural Block Diagram of 8051 Microcontroller. So before moving to the these lessons, let us come to the lesson outcome. After end of these presentations, the student will able to understand the internal architecture and the functional blocks of 8051 microcontroller, and they can also able to explain the role and interactions of major components such as ALU, CPU, memory, timer, and the serial ports. So let's start with the today's sessions. So this is the basic structure of the 8051 microcontroller. And whenever we'll start the architectural structure, the first that is came into the picture is CPU. We all know that the CPU stands for the central processing unit. And this CPU is actually responsible for performing all kind of arithmetic as well as the logical operations. Now, in case of this 8051 microcontroller, this CPU is 8-bit. What does it means? It means that the 8051 microcontroller at a time it can process 8-bit of data. That means whenever we are going to perform any kind of the logical and arithmetic operations that can be performed within a 2 8-bit data. So that's why the 8051 microcontroller having a CPU of 8-bit. After that, it has a 4K on-chip flash. Means we know that whenever we are talking about the microcontroller, specifically the embedded systems, uh, after the CPU, the main vital part come into the picture is the memory. And we know that there is two types of the memories are there. One is the ROM memory, another is the RAM memory. In case of this 8051 microcontroller, internally it have 4 kilobyte of on-chip ROM, which is also known as the program memory. That means internally it have 4 kilobyte of space, and that space is used to store the program within that 8051 microcontroller. Apart from this on-chip ROM, it have an on-chip RAM also. And this on-chip RAM size is 128 bytes. So this 128 bytes is also known as on-chip data memory RAM. That means this specified memory location is mainly used to store the data during the any kind of the operations. After that, this ROM and RAM structure, it has some bus controls module. What is the meaning of this bus control module? Although this 8051 microcontroller have some amount of on-chip ROM and on-chip RAM, it might happen that apart from this on-chip ROM and RAM, a particular operations require more memory. For that case, we need to externally interface a external memory. And for that externally interface memory, this 8051 microcontroller have 16-bit address bus as well as 8-bit data bus. And through this 16-bit address bus and 8-bit data bus, this 8051 microcontroller can able to interface 64 kilobyte of program as well as data memory address space. That means it can externally also interface this 64 kilobyte of address memory as well as, sorry, the program memory as well as the data memory. And to do so, this bus control taken into the place. So you can see that in this bus control module, there is two signals are there. One is the PCN bar, another was the ALE. So the full form of this PCN bar and the ALE is program store enable for the PCN bar, and ALE stands for the address latch enable. So we'll discuss further on these two signals, how these two signals is going to help us for the external memory interfacing during the interfacing sections. After this bus control, this 8051 microcontroller have some timer or counter sections. The use of this timer and counter section is that using this timer and counter sections, the 8051 microcontroller can generate the internal time delay as well as we can use these sections for the counting operations. To do so, this 5-1 microcontroller have two 16-bit timer and the counter. So those are named as timer 0 and timer 1. We can also say it at a counter 0 and the counter 1. So it have a two 16-bit timer counter that we can use for the time delay generations and the counting purpose. After that, you can see it have some interrupt control sections. This is a very interesting part is there that this 5.1 supports some interrupt control structure. Why this interrupt control structure is required? Because it might happen that during the normal operations, some external event or some internal event try to interrupt the normal sequence. And in these situations, this interrupt control structure is very essential to organize a multiple interrupt at a time. That means, for example, I can say one thing that say at a time two interrupt come into the place. So which interrupt that microcontroller serve first, that will actually depends on this interrupt control structure. So this 5.1 microcontroller have an interrupt control structure, and the 8051 microcontroller have total six source of interrupt. Among these six source of interrupt, it have five vector structure, vector interrupt, I must say. During the microprocessor sections, probably people know that what is the difference between the vector interrupt and the non-vector interrupt. So here, this 5.1 microcontroller have total six number of interrupt sources. Among those sources, five vector interrupt structure is there. And among these six sources, it have two external interrupt and all other the internal interrupt. So that's why you can see these external interrupt sections, it will observe, you can observe that two arrows are there. So that signifies that this 5.1 structure supports two external interrupt. Okay. After that, it have four input output ports. Okay, and we know that one port having a 8 data lines are there, 8 bits are there, and these four ports are named as port 0, port 1, port 2, and port 3. Why they are written in a particular fashion, that port 0 and port 2 consecutively and port 1 and port 3 consecutively? Don't be confused about that, because whenever we will see in the next lecture the pin configuration, we can observe that the port 1 and port 3 are come in a single side, and on another side the port 0 and port 2 will come. That's why it is written so. You can also write it down that port 0, port 1, port 2, and port 3. That's not a big problem. In these sections, it have 32 bidirectional and individually addressable IO line. That's most interesting part is here. Why 32? Four ports are there, and individual port, 8 lines are there. So 8 multiplied 4 is a 32. So it have a 32 IO lines. So whenever I am talking about the IO lines, that should be bidirectional, because whenever I am taking an input through that line, that's the input line. Whenever I am giving the output through that line, that will be act as the output line. So it's a bidirectional. And another part is that individually addressable. That's one of the greatest advantage of the 5.1 microcontroller over the 8.5 microprocessor, that I can address individual lines of individual port. That means, say port 0 having 8 lines from port 0.0 to port 0.7. If I need to access a single line of a port 0, say port 0.2, my 5.1 microcontroller will support these operations. But in case of the 8.5 microprocessor, we have to address whole ports. We will see in the microprocessor sections. So that's one of the advantage of this 5.1 microcontroller, that all these 32 numbers of the IO lines are individually addressable. I can individually, or we can individually access all those IO lines. Okay. After the port, it have a serial port, and this serial port supports the communication purposes. This is used for the communication purposes, right? And this is the serial port. That means this 5.1 microcontroller supports the serial communications. and it have a full duplex UART. I think all of you know what is the definition of the full duplex type of the communications, because there are three types of the communications are there: simplex communication, duplex. Inside of the duplex, there is a half duplex communication, there is a full duplex communications. Okay, we will definitely discuss more about this duplex type of a full duplex type of communication during the communication lection. So here you just discuss about the things that it supports the full duplex type of the communication and UART. What is the full form of UART? UART stands for Universal Asynchronous Receiver Transmitter. That means this 5.1 microcontroller supports the asynchronous communications. It doesn't have the USART. It have a UART. So this supports the asynchronous communications. Okay, we will discuss further about this communication purpose during the communication lections. And you can see here in this structure, it have a two lines. One is the TXD. TXD stands for the transmission line. One is the RXD. RXD stands for the receiver line. And you can observe, you can also see the direction of this TXD and RXD. TXD is outward directions because transmission lines, we are transmitting the 5.1 microcontroller, transmitting something means that will be the outgoing situations, outgoing lines, right? And receiving means that was the inward directions. Okay, so that's why the RXD in the inward directions, TXD in the outward directions. Okay, so that's a serial port. Lastly, it have a oscillation circuit, oscillator circuit, and these 5.1 microcontroller have a on-chip oscillator circuits. On-chip oscillator circuit means we need to connect the crystal oscillator externally, but it have a on-chip oscillator circuit that will actually divide this clock frequency into 12 T state, and the 5.1 microcontroller we will see in the next lessons that the one machine cycles it stands for the 12 T states. Okay, so it have an on-chip oscillator circuit that inside that 8051 microcontroller. So this is the all about these are the modules are actually there inside the 8051 microcontroller, and all those blocks are connected through an internal bus. Okay, that means the on-chip ROM, RAM, timer counter, serial port, IO port, bus control, infrastructure. All those are things are connected via internal bus connections. Now here I must say one thing, that whenever we are connecting this internal bus structure, one thing we should observe over here, that in case of this on-chip flash memory, that is the ROM memory, this is not the bidirectional line is there. This is the unidirectional line. Why? Because we know that in case of the ROM memory, we can only read, we cannot write. But you can see this is the RAM memory, the bidirectional lines are there. So you can read from the RAM memory, you can write into the RAM memory. But in the ROM memory, only we can read. That's why the direction is the unidirectional, right? So this is the overall architectural structure of the 8051 microcontroller. Now, Now, this is the comparison between the 8051 family members. Why I said this is the family members? In the 8051 family member, mostly there are three members are there. One 8051 is there, 8052 is there, and 8053 is there, 8031. Now, as we already see in the last slide, that it have some on-chip ROM, it has some on-chip RAM, timer counter, and all those kind of thing. But if you see in the different family members, that is a 5.1, 5.2, and 3.1, the value are going to be changed. How we will see these things? That the on-chip ROM size, in case of the 8051, we'll already observe this is a 4 kilobyte of on-chip ROM is there in the inside that 8051 microcontroller. But in case of the 5.2 microcontroller, it is 8 kilobyte, just doubled. In case of the 3.1 microcontroller, it's very interesting. There is 0 kilobyte of on-chip ROM. That means no ROM is there. And that's why this 8031 microcontroller is also known as ROM-less microcontroller. Okay, so if we use the 8031 microcontroller, definitely first and foremost thing is we need to interface external ROM first. Then only we can use this 8031 microcontroller, because it's a ROM-less microcontroller. Okay. Second feature is the RAM. We can see that 8051 and 8031 both having the same RAM, that is a 128 byte, but 8052 have 256 byte of the RAM. In case of the timers, 3.1 and the 5.1 having two timer counter, we already observed in the last slides. But in case of the 8052 having a three internal timer counter. In case of the IO ports, all the family members have same number of IO port, that is a 32 numbers of bidirectional individually addressable IO lines. In case of the serial port, all having a single serial port. But in case of the interrupt source, as I already said in the last slide, that 8051 having a six source among these five vector interrupt are there. So 5.1 and 3.1 having the same interrupt structure, but in case of the 5.2, it have additionally two interrupt sources are there, and in case of this microcontroller, the number of interrupt sources is 8. Okay, so this is basically a comparison table among the different 8051 microcontroller family. Okay, so that's all for this lesson. See you in the next lesson. Thank you.